Hello everyone, greetings of the day. Dear authors and invited guests, welcome to the technical session 6D. Myself Prashi, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics LLP, it is my great pleasure to welcome you to the 10th International Conference on ICT for Sustainable Development ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17th to 19th of July 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for questions and answers. On the ninth minute, I will be raising a gentle reminder. There is another request to all our participants that you stay connected to us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box down below. Just before we start the session, I would like to introduce you all to the chair of our session, Dr. Deepika Saxena. Dr. Deepika Saxena is currently serving as an associate professor at Purnima University with a PhD in cloud computing and over 15 years of teaching experience. She has demonstrated expertise in areas such as cybersecurity, container security, and cloud computing. Dr. Saxena is an active member of ACM and ING. We welcome you to the session, ma'am.
Thank you so much, ma'am.
Thank you so much for your presence, ma'am. Would you like to say a few words before we start our session today?
Yeah, ma'am. Yes, ma'am.
Ma'am, would you like to say anything before we start?
No, ma'am. Thank you so much. You can start your session.
For sure, ma'am. Thank you so much. So, as permitted by ma'am, let us take our first presenter of the session, Bhavna Garagan, presenting a paper on the title, A Vision-Based Blind Spot Warning System for Autonomous Driving. I request you, if you're available with us, kindly take over with your presentation, please.
So, good afternoon, everyone. I am Bhavna Garjan from KLE Technological University, Hubballi, and today I'm here to present on behalf of my team. I'm here today to present our work or paper on a vision-based blind spot warning system for autonomous driving. This work was carried out in the guidance of our professors, Mrs. Nalini Iyer, Mrs. Prabha Nissamagowda, and also collaboration with my teammates, Harshit Kadam, V. Harshavardhan, and Srigaran. So, so our work deals with the crucial safety conditioning in the modern vehicles called as blind spots. So let us proceed. So first of all, as part of introduction, I would like to say what is blind spot. So blind spots are basically that part of vehicle where a driver's visibility is limited to see what's there in that particular area. For example, the rear end of the car or vehicle where a driver cannot see that those sections or areas properly. Those are referred to as blind spots, and blind spots in vehicles have the risk of collision during changes while lane changes or turnings, or also while taking reverse, etc. So existing blind spot systems actually fail to provide dynamic detection. Hence, we thought of trying a vision-based approach to this problem. So this is what it is. So as I explained, what are blind spots? Area around the vehicle hidden from the driver, either through windows or mirrors. Even where windows or mirrors, those areas are not visible. So these pose a risk to often obscure other cars, pedestrians, etc. So yeah. Okay, motivation for our work was basically the rare vehicle blind spot detection systems. They minimize, they don't detect the vehicles which are present properly. The existing object detection methods does not support to do so. So there is risk for driver's view, etc. So that was the motivation behind. Yeah, like our objectives include the following. Like we thought of, like our solution included these steps. First, we thought of drawing, like for the video feed, we used the we thought of drawing the ROI or region of interest, then calculating the region of area of the region ROI, then defining thresholds, then distance calculation and alert generation. So yeah, this is our algorithm. We initialize the yellow model, then defining the ROIs. Here we have used 4-point and 6-point ROI methods, and then loading the class labels, setting up the video stream, define mouse callback function. This was for drawing the ROIs. We actually did trial and error method for doing so. Like we defined a mouse function. Whenever we place our mouse cursor, that will give the coordinates of the particular video feed. So hence we use that. Then beginning the begin the video processing, then read and resize the frame, then perform YOLO object detection. We use YOLO V8, and then extract bounding boxes, class IDs, and object centers. Then filter. Yeah, for the particular ROS, we defined the threshold. Like it was pixel threshold. Like width was 90 and the height was less than 10. Um, then checking the objects which are identified under the ROI, and using point polygon test to check whether the object lies in the center of the ROI. So that's what we did. Then generating alerts. So whenever there's a vehicle present in the ROI, whenever it reaches the threshold, it will generate an alert like saying caution, an object is there in the blind spot. And yeah, this is pretty much what we did. And this is our, like whatever I've explained, this was the like our system flow includes this model initialization, video capturing, region of interest, then threshold. Yeah, this is what we did: object detection, then alert generation, and output video. And also, this is our system architecture. We considered 4DV dataset, which is a very standard dataset available, and processing the dataset, that is image resizing, data augmentation, etc. Then we custom print our YOLO using Roboflow. That's what we did. This is image stitching. Actually, the 4DV dataset which we got was an image format. Uh, to process the blind spot easily, we thought of image stitching, that is converting the images to videos. Hence, stitching is involved in here. Then, as I explained earlier, drawing ROI, then polygon definition, etc. Are considering the ROI, then distance calculation, area calculation, threshold check, alert generation. Then, yeah, this is pretty much it. Methodology also explains the same thing. And yes, this is what capturing the video feed, then YOLO, feeding the YOLO model, object detection, alert generation. So this is what these two slides explain the same thing basically. Then this is description about our data set. The input is the video sequence. We stitched the images and we got the video sequence. And the standard dash cam of the 4AV which we have used uses 120 to 130 degree of field of vision. Then there are, like as described here, there are each log contains 7 cameras from the vehicle, 2 from front and rear. These are the specs of the cameras, like 1.3 MP stereo pairs operating at 15 Hertz, and 2 side binocular cameras which work at 15 Hertz. Then the 7th front dash camera produces 5 MP images at 6 Hertz. So yeah, this is what. Okay, and the dataset consisted of 16,539 images. Using RoboFlow, we individually annotated these images. Then the dataset was split into 15% validation, 5% testing, and 80% training. Uh, yeah, for blind spot detection, we approached the 4-point and 6-point ROI method. I'll explain what it is. Okay. Then, as I said earlier, this also involves the same steps: object detection, threshold checking, size filtering. That's it. So this is actually for this is how the result we got the result. This is 6-point polygon or ROI which we drew here. and the threshold is set. Even threshold is set for less than 10 and less than 90 width and height of the pixels, camera pixels. So even though there is an vehicle entering in the ROI, it's not giving alert as the size filtering is done or threshold is given. And here we see that object is entered the threshold, hence it is identified and the caution is given. And this is 6 point ROI based. And similarly in 4 point, what happens? Here also we had done the same. The ROI is there, and whenever the threshold is matched, then only the alert is generated. So yeah, this is how we got the result. We consider like according to the results, 6 point ROI is better than the 4 point ROI because in 6 point ROI, more precise coverage of the blind spots is there, and also better adaptation of vehicle geometry is there, and improved localization of with accuracy is present. Hence, 6 point ROI is better than the 4 point. Uh, yeah, like these were the outcomes. Dynamic monitoring of left and right rear blind spots, then accurate object filtering and sensor-free approach. This is, yeah, sensor-free approach. That is what we have done. Like this is vision-based purely. We used ML models, that is YOLO V8. Hence, it is sensor-free and vision-based. Then enhanced situational, it has enhanced the situational awareness for the drivers uh, to promote safer driving, etc. So that is it from my end. Thank you.
Thank you so much for your presentation, ma'am. Ms. Saxena, ma'am, do we have any questions for her?
Yes, yes, ma'am. I want to know about the parameters. What type of the parameters you are using regarding your result? Please define it.
Yeah, we have used like we have considered precision as the main factor, ma'am. Actually, I think it's there in the paper. Just a second. I think, yeah, I actually have that. It actually tells about the precision. We have considered the precision and count of like true positives and false negatives because true positives are required. Like if an object is there in the ROI and if it is detected properly, then true positive works fine. And we have considered the less number of false positives. Like if there are less number of false positive, then the model works properly. And both of using true positive and false positives, we have calculated the precision. And actually, in our paper, that's we had I actually have the table. I'm so sorry, it's missing here. I think that was in another PPT. But yes, our um, our paper had that results section which showed like 6 point polygon shows 80% of precision, whereas the 4 point polygon shows 67% of the precision. I will just show you that. I'm so sorry, I did not include this in the PPT. Just a second.
Okay. Now, please, next one.
I'd like to call upon our next presenter. Our next presenter is Shareem Iqbal presenting a paper on the title Design and Implementation of a Secure QR Payment System Using Visual Cryptography. So if you are available with us, I request you to kindly take over with your presentation, please.
Yeah, so let's get started. So good afternoon, respected teachers. I am Sharim Ansari, a student of MTech Information Technology. I am from the college KJ Sumaiya, College of Engineering, and today I will be presenting my research project, which is called Design and Implementation of a Secure QR Payment System using Visual Cryptography. This project is completed in the guidance of Professor Purnima Ahirao ma'am and Professor Deepti ma'am. So let's start with the introduction. So as you know, QR code payments are widely used today for fast and its contactless transactions. QR usage also has been increased 43.2% since 2022, and approximately 80% of the digital transactions in Asia are done through QR codes. With this growth in increase of QR code, the concerns security concerns are also rising. So traditional encryption techniques alone are not sufficient to prevent from attacks such as QR tampering, phishing, and cloning. So we propose a secure solution, which is visual cryptography. So in that we not need complex decryption. So our main objectives of this project is to develop a tamper-proof QR codes by splitting the payment data, which is the payment URL, into two visual shares, like meaningful shares using visual cryptography, and to prevent phishing and cloning attacks through real-time validation, use HMAC, which is hashing message authentication code for message integrity and transaction integrity to block malware and malicious URLs and multiple application extensions using Google Safe Browsing API and to comply with PCI DSS security standards. So what is a QR code? QR code is basically a two-dimensional barcode which is capable of storing large amount of data, small data, for example, URLs, text, or payment details. It uses encoding methods like Reed Solomon encoding, and they consist of black black squares arranged on a white grid, which can be scanned through cameras and other multimedia devices. So to generate a QR code, the input data first is analyzed and divided into smaller data blocks. Error collection is applied. Error collection is applied to ensure data recovery if the data means payment URL is partially damaged. And after that, the data is encoded into binary sequences, says 1001, and then these sequences are placed on the predefined grid like white and black grid. This grids is the final code which is displayed as a pixelated square to the user. So our proposed methodology is a visual cryptography. It is a cryptographic technique where an image is divided into multiple parts, or you can say shares. The key benefits of this visual cryptography is no complex decryption required. It is an image-based cryptography rather than traditional key-based cryptography, and no need for key management. The applications of visual cryptography include secure QR codes, authentication, login purposes, sharing Wi-Fi password, and image sharing. So we have used an algorithm called 2v2 visual cryptography algorithm. It is a part of visual cryptography algorithm in which secret image is divided into two shares. One share is stored on the server, and the second share is sent as a QR code to the user. One After user scans the QR code, then it combines the server share data with the client share data and then check whether the payment is authentic or not. So this the formula of the share creation, as you can see, each pixel P is divided into secret image. We are using logical XOR operations to generate QR codes. So this is the flowchart of the overall system in which user first initiates the payment through the merchant application or merchant POS. Then merchant sends the payment details like user ID, transaction ID, merchant ID to the server, and then our server, which is visual cryptography engine, fetches data from the bank, and then it generates a payment URL which will be sent to the payment gateway. So the payment URL first it's divided into two shares, server share or and client share. Then when user scans the QR code, uh, one API is called to the server, and then it checks if the client share is proper or not by combining both the shares. We are also validating the transaction through transaction ID and which real time checking for replay attacks, and we are also checking by generating HMAC authentication code. If any three of the validation steps are failed, transaction will automatically be declined. So this is our methodology in which the QR code is split into two shares. Uh, One share is sent to the user as a QR code, and the second share is stored on the server. The server combines its stored share with the scanned share which user has scanned, and then it reconstructs the original QR code. So how authentication issue is solved, because in traditional QR systems the QR codes are usually static and they are not dynamic, so they don't confirm the identity of the person, not the merchant. So to fix these issues, visual cryptography we use visual cryptography, in which we send merchant ID, transaction ID, and user ID and HMAC to the server to authenticate and verify the integrity of the transaction. So this is the mathematical equations. First one is the original payment URL is encoded as a QR code, which is encrypted using basic substitution cipher, where we use a function which substitutes the payment URL and generates a string. And then second encryption we are doing is using visual cryptography. And then the encrypted QR code is divided into two shares of random images or bytes. And then when user scans that QR code, we will send that QR code data, share one data to the server, and then server applies XOR operations to check if the data is authentic or not. It also verifies the integrity of the transaction as well. So this is the UI of the methodology. Like on the left side, you can see this is the QR code generation, in which merchant can enter multiple amounts, and then when the merchant clicks on generate QR code, this is the sample QR code. When the user scans that QR code, we will do the arithmetic operations on the backend server. So this is the sequence diagram, and this merchant initiates the transaction, and then our visual cryptography system fetches data from the payment, and then it also splits the data into visual cryptography shares and sends one data to the user for QR scanning. When user scans the QR code, the share one is validated to the backend system and visual cryptography system. If the all three validations are completed, then it is redirected to the payment for complete payment. It is redirected for payment completion. So we have also compared this cryptographic visual cryptography with the traditional AES and RSA encryption for encryption and decryption time. So as you can see, visual cryptography has subsequently lower encryption time and lower decryption time as well as compared to AES and RSA. So visual cryptography, we are using visual cryptography for low-end mobile devices, which has low resources. So our proposed QR payment systems using visual cryptography provides a secure and efficient method for online payments. Our system addresses the current limitations of existing QR payment systems, which are vulnerable, and also our proposed system outlined integrates various visual cryptography into QR system to enhance the security. So future work will include, we can also do encryption and decryption of client share, and we can also authenticate with the biometric, like we can also authenticate with the fingerprint or face scan with the, because we are using in the mobile devices. And also we also you can do performance optimization, where in which we can use various VC algorithms like QEVCS and K/N algorithm. And also we can use AI driven threat detection to detect various attacks which are being held on the QR payments. So these are the references which I have taken. Thank you. This is from.
Thank you so much, sir. Ma'am, do we have any questions?
Yes. Mr. Iqbal, can you tell me are you tested this system? You said to me ki like This is the system. So, are you tested this system?
Yes, I have tested this system in various scenarios in various devices.
And
This is
which
the
type of tool you used for this testing?
for backend. I have used to test APIs. I have used Postman, and for
Hmm.
front end, I have deployed the front end at Vercel site. And for the backend, I have used ngrok to expose local host to the real world.
Okay. And what the accuracy you got?
I have got around comparing to traditional encryption system, I got like around 2000 milliseconds per transaction, whereas I
Mhm.
have also compared the traditional systems in which it is around 3000 milliseconds.
Okay, fine. Okay, Iqbal, thank you so much.
Yeah, thank you.
Thank you so much for your presentation, sir. Now I'd like to call upon our next presenter for the session. Our next presenter is A. Akshaya, presenting a paper on the title Enhancing Sentiment Analysis of Movie Reviews. I request you to kindly take over with the presentation, please.
Yes, ma'am. Ma'am, can you see my screen, ma'am?
Yes, ma'am, it's visible.
Ah, okay, ma'am. Good afternoon, ma'am. I'm Akshaya and I'm here to share a project that my team and I worked on titled Enhancing Sentimental Analysis for Movie Reviews under the guidance of Sushma Rani Dutta, ma'am. It is a mix of classic sentimental tools and deep learning, and our goal was to see how well we predict what people feel about movies. Uh, as per the introduction, uh, what is sentimental analysis means it is a technique in NLP that helps computer understand whether a piece of text is positive or negative or neutral, ma'am. Now as we all check reviews before we watch a movie, these reviews are full of opinions, and understanding them automatically at scale can be very useful, not just for audience but also for filmmakers and streaming platforms. We explore two types of tools for this. One is for traditional lexicon based tools like TextBlob and VADAR, and for deep learning models like GRU, which is a type of recurrent neural network, ma'am. Here, tool as we know, tools like VADAR or TextBlob work well for simple text, but they often fail with complex sentences, especially if there is a mixed emotions or content switching. Our idea was to test whether a deep learning model like GRU could be better, especially if we feed it to smarter inputs like using word to vector embeddings. We had four main goals, ma'am, like compare TextBlob, VADAR, and GRU, and use through the GRU model, and to evaluate all models with standard matrices, and also to propose a hybrid method that balances accuracy and efficiency. Our approach was we used the IMBD dataset, which consists of 50,000 movie reviews, which equal number of positive, negative samples. For pre-processing, we cleaned up the text by removing things like punctuations and HTML tags and lowercase everything, and then applied stemming. These gives us clean, standardized input. For lexicon tools, we just ran the clean text through their APIs, but for GRU, we needed numeric vectors, so we trained the word to vectors embeddings with 1000 dimensions, which helped the model understand the meaning and relationship between the words. Our GRU model was pretty straightforward. First, we passed the word to vectors into an embedding layer. Then we had a GRU layer to capture word sequence. Finally, a dense output layer was sigmoid activation, gave us the symbol sentimental label, which is positive or negative. As per the This is the functional block diagram that we gone through. Data collection was that IMBD dataset from the internet, from public dataset. They store the TXT form files plus sentimental labels in a secured bucket or local folder. And for data pre-processing, we lowercase text, strip HTML tags and punctuation and emojis. We removed stop words, tokenization and lemmatization for more pre-processing and for more accuracy. As for feature engineering, there were two parallel tracks. That is lexicon models, that which goes in as in, and whereas sentimental is locked up by word. And for model selection, we decide text blob and wader, and also GRU lighter weight than, which is lighter weight than LSTM, still good with sequences. And for model selection, we did for as for model selection, we selected lexicon models, as they no need training, they run immediately. And also GRU has the embedding GRU. uh, and for model, sorry ma'am. For model evaluation, we ran the model on the held out IMBD test split and compute. We compared accuracy, precision, recall, F1 square for all the for all the like GRU, text blob, WADR, and word to vector. This is what I said. As for feature engineering and model selection, we did a lexicon based, no as they know need for feature extraction. For GRU model, we trained word to vector embeddings. Vector representation captures sentimental relationship between words. Lexicon, we also use lexicon based models, that are text block and WADR. For deep learning models, we use GRU, that is gated recurrent unit. As per the model training and evaluation, uh, there were 25,000 training models and 25,000 testing models in the IMBD dataset, and the dataset only contain text like models. This is the model performance, ma'am. And the conclusion was lexicon based models are fast and simple but not smart enough for languages. GRU, on the other hand, takes more effort to train but gives much results, especially when combined with embeddings like word to vector. Our hybrid method, using both traditional tools and deep learning, offers a more accurate and context, especially for real world applications like reviews and social media. Our future work, we are still working on it, ma'am. We would like to move forward like aspect based sentimental analysis, where we figure out how people feel about specific part of a movie, like acting, music or direction, ma'am. And we also plan to expand these to other languages using transfer models like BERT. And finally, we are looking into real time sentimental analysis, ma'am. That's it, ma'am.
Thank you so much for your presentation. Ma'am, do we have any questions for ma'am?
No, ma'am. No, ma'am. Thank you.
Thank you, ma'am.
Thank you so much for your presentation. Our next participant is Praveen Varunshi, presenting a paper on the title Modeling Comprehensive Web Framework for Enhancing Administrative Efficiency in an Educational Institution. Do we have you here right now with us?
Yes, ma'am.
I request you to kindly please take over with your presentation. Sir?
So, hello everyone. I'm Pranav Varungashe from Episha Institute of Technology. I am here to present on a paper with title Modeling Comprehensive Web Framework for Enhancing Administrative Efficiency in Educational Institute. We have worked on this project with my group, which includes Siddhi Desle, Sushant Matre. We were guided by Ms. Rujata Chaudhary ma'am and Ms. Sally Laplikar ma'am. So this will be the content of my presentation. First, in introduction, we there will be problem identified and what solution we are going to propose. So in current situation where college don't have a streamlined system for overseeing or prioritizing application, which make administrator to collect data on a paper. We create we manage this problem into our solution. Also, there is currently alumni face issues in managing their post-graduation processes, such as tracking their living certificate, mark sheet, or letter of recommendation. We also propose solutions for that. So we created a cross-platform web application and mobile application using React and React Native. This helps them track. This helps students track the application at which state they are. If there is any correction, they can apply for that document directly online without visiting the college. We have also created this system so that teachers can keep track of all the students who have collected and pending applications online in a one place with a graphical way. So our proposed system in proposed system, we have user login, alumni login for alumni and faculty. In alumni side, we have dashboard where student have applications they can apply to, such as living certificate or LOR or mark sheet. Once application is applied by student, soft copy is submitted to the teacher. They can verify their data and generate the document. If there is any issue with data student have uh, submitted, they will again have to resubmit the data by correcting the incorrect information. On mobile application, we have only keep it for tracking purpose, where user will get every not, notified by faculty of every step when there is change in the state of their application. On on the faculty side, we have login. Once faculty login, they will be redirected to dashboard where they will be shown the data of current application in a graphical way where they can manage. They can also download this graphic data, which include number of application have which have applied, number of students which have collected the documents, number of students who do not currently completed the process, which are notified to them. Uh, there is a section where teachers can verify the submitted data of a student and process the documents. Uh, Once verification is done by teacher, application generation process will start where they can uh, prioritize any document if the student require it on urgent basis. Once this is done, student will get notification of that state and he can track the document on our application. In workflow, initially teachers have to start the process of applications. Once teachers start that process of application, student will verify the data submitted on a college portal. Then the verification process, once verified, student verify that data, they can submit the application. Then document generation process will start. Uh, Once document generation process start, application is redirected to admin office where they will verify the document submitted by student. If there is any issue with that document, they will redirect it or notify the student to correct the information. Once that is done, uh, the there will be check of a due pending by student. He will requested to pay if there is any due pending. Once he pays the due, student will get notified to when he can collect the document. In scopes, this project aims to develop a robust system where alumni can keep track of their post-graduation documents. and applications such as living certificate, mark sheet, and etc. Uh, this ecosystem will allow faculties to keep track of pending and completed document efficiently in a graphical way. The system will enable administrator to prioritize the application that require urgent attention. Like in some cases, when students require to submit document for their masters or in offices or office, they need it in urgent basis. Teachers can prioritize that document and he will get it as quickly as possible. In future, we can integrate the document verification process via AI. With AI, so there is no manual verification of document needed, and we can also add a predictive analytics, which will help institute to anticipate alumni need to enhance their experience in more good way. We can also add a blockchain technology to im- uh, technology to make sure all the documents are secure secure and student don't have to worry about the document they have submitted. This will very this will enhance the authenticity and prevent fraud. In conclusion, the streamline this system streamlines the service, uh, alumni service by integrating LC/LOR application into one platform. We have dual interface system, so alumni can track the applications in real time via web portal or either mobile portal. They will also get notifications for the process. Uh, this will enhance the communication between alumni and faculty, improving transparency and workflow efficiency of a college. This application is built with React Native and ensures secure access, intuitive and structured data exchange through API to the web application or mobile application. Thanks. Thank you, ma'am.
Pranav,
Yes, ma'am.
yeah, this model is based on machine learning.
Oh, no, ma'am.
Okay. What type of algorithm you are using in this system?
It's not based on machine learning. We haven't introduced it.
Uh, so what the platform you are using for execution this?
It's a web application and mobile application.
Okay, it is from mobile application and uh, okay, like uh, uh, show me this future work also, no? Please show me the slide of the future work.
This is
Yeah, this first line, no, this first line, the system will integrated AI driven automation to expedite document verification and process. So, have you any planning regarding this area? How you
no,
will
ma'am.
actually?
We haven't
You just
decided on it yet.
it is your planning in a future
Yes,
you can okay.
introduce it.
Fine. Actually, it is a very interesting topic, and you can execute in your uh, in next research. You can execute with the AI using, no?
Yes,
So
ma'am.
you can implement it by AI or AI like algorithms. So definitely you got the good result on this, no? Okay, thank you, Pranav.
Thank you, ma'am.
Okay.
Thank you so much for your presentation.
Ma'am, can I leave?
Sir, I will request you to kindly stay till the end if possible because we'll be having a screenshot of our session.
Okay, ma'am. Thank you.
Thank Now I'd like to call upon our next presenter, Abhishek A. Joshi, presenting a paper on the title Oral Disease Detection Using Multimodal Fusion. Requesting you to kindly take over with your presentation, please.
Yes, ma'am. Good morning, ma'am. Good morning, everyone. So I'd like to share my screen.
So is my screen visible? Hello?
Yes, sir. One
Ah,
second.
yeah,
Now it is visible.
yeah. So good morning, everyone. Good afternoon, everyone. So the paper title is Oral Disease Detection Using Multimodal Fusion. So the authors of the paper is myself and Vasudhaka Simshana, under the guidance of Professor Kaushik Malibat sir and Satish Chikmat sir. So Uh, the introduction, the project aims to develop a multimodal, multi-class classifier using the to classify the disease, oral disease, basically by taking the input as both the image and the symptom. So we are aiming for 7 classes, that is like oral cancer, hypodontia, tooth discoloration, and so on. So the main problem statement of this project was build a multi-class classifier that diagnoses oral diseases based on a multimodal approach using images of the affected area and symptoms. So the main idea behind this project of making this model was that uh, we have models such as oral disease detection just using images or just using symptoms, but there was not a model. There was never a model where both images and symptoms both are put into input. We are getting result based on that. So just making image, taking image as input, and if we predict some output. So there was already a paper which was solely based on image as input. So that had accuracy of 80%. So but just a symptom as a input also won't be so clear, that because we can't define that a symptom very clearly. But when we put image, the affected area, disease affected area as input, and if we put a symptom correspondingly according to the particular image, then we can get a better output. That was the main idea behind this. So methodology also follows in the same way, where we put image and symptom parallelly as the input, and that is this image as put into image vision, computer vision model through transfer learning, which we use in MobileNet V2 model. And symptom for the symptom analysis, we have used logistic regression. Both from these both we are finding confidence scores on all the classes which has been produced by them, and these confidence scores are being used as data set for the next decision level fusion block. That is again we are using a logistic regression, which is then we are training all these confidence scores with we have a data set through logistic regression model. And by giving, now we are giving input for that particular decision level fusion block, and we are gaining the output. So we have used data sets for oral diseases. That is these two data set, oral cancer, we have taken from different data set. And for image classification model, we have used in MobileNet V2. Why we use in MobileNet V2 was because that was the model which used which where we got highest accuracy just solely based on the image. We have tried with many other models. Even we have developed our own CNN model after analyzing and using all the pre-trained models. And we trained the data set for each model, and we tested it. After all the analysis and results, we have finalized this MobileNet V2 model, and we use a transfer learning technique to integrate this model in our project. And for symptom classification model, we have used a logistic regression. So basically, we have converted all the symptoms into tokens. So these symptoms were not just like a single words; it was a full sentence. In that sentence, we extract the main keywords, and we train it with a predefined data set. And when we give input the basically the logistic regression will classify, will give the probability for all the classes, that what probability this symptom can match to that particular class. So decision level fusion layer is basically we are taking confidence scores along with the true label. So in confidence scores for symptom based model, it may be like the confidence score for gingivitis may be high, but true label may be calculus. And image based model where calculus may be high and or others may be low. So when we train in this way, for n number of samples, we have trained literally for 1500 samples, we have iterated that many times. So after training all this, we are getting final model where when we give the confidence scores of logistic regression and mobile net v2 for new image and a new symptom, then the combinative output from this model it has the more weightage and it has more accurate. The results are more accurate than the just individually solely based models. So MobileNet V2 model achieved an average of accuracy of 81%, and the highest accuracy was 84.14%. It was on 21st epoch, and the symptom-based model, which was a logistic regression model, was trained with 150 different combinations of symptoms, and each class splitting the data set into a train and test set ratio of 4:1, and accuracy of this model was 97%. But if we go just based on accuracy, so when we write a symptom based on the what we feel, that may be not as accurate as what we write, because we may feel something inside, but the what it looks like, the affected area, what it looks like also matters the most. So when we fuse it the model, and we can't exactly say what accuracy of the model is, but when we tried and tested for many more combinations of the results. So for example, let's see the results. So this was just MobileNet v2 models results. So we can see in the first image, the true class was calculus, but the highest probability we got for gingivitis. Here it was oral cancer, but we got for gingivitis. In the same way, here it is mouth ulcer, but we got highest probability for oral cancer. This was just based on the what they say symptoms. So when we combine both of them, we have used the same image and we have corresponding symptom according to the image. We can see calculus has been selected the most, and the gingivitis, and here the results are more clear, and the probability for the true class has been increased, and we are getting output as that particular result. So our model excels in this particular area. So the conclusions we draw from this is that the proposed framework has a novel method for detecting oral diseases using a multi-model approach and improved accessibility and oral healthcare. Study leverage a decision level fusion mechanism to enhance diagnostic accuracy. So future work is that we can do it with many other diseases, and it is even this this model is not even expensive. So this can be used by even the users, not just it is used in medical field. This can be used with all the patients, and even in paper we have mentioned how this can be how this is very like in there are some areas where there are no dental hospitals. Then even users can test their oral diseases very early, and they can get pre-diagnosis results very soon. So thank you. This was my presentation.
Thank you so much, sir.
Yeah.
Ma'am, do we have any questions for sir?
No, ma'am. Thank you.
Thank you, ma'am.
Our next presenter is Tiwari Prashant Dinesh Kumar, presenting a paper on the title Sustainable Electronic Waste Management Through Effective Power Management for a Greener Future. I request you, sir, if you are available with us right now, kindly take over with the presentation, please.
I am audible, ma'am?
Yes, sir, you're audible.
Okay. Good evening, everyone. I am Prashant Tiwari from the Department of Power Electronics, Vishwakarma Government Engineering College, Ahmedabad. Today, I am pleased to present our research title, Sustainable Electronic Waste Management Through Efficient Power Management for Greener Future. It is designed first vision for a cleaner planet. We take a fast-paced journey from the scale of the e-waste crisis to solution driven by economics to how smarter design can change the way we build our futures. Every year discard over 57 million tons of electronics, more than the weight of the Great Wall of the China. Yet less than 1 in 5 devices are recycled. That is not just waste, that is the loss of opportunity. And it is a result of poor designing, not just poor disposable. The real problem is not just disposable, it is the way we build things, appropriate connector, short-lived PCBs, devices that are not designed to last, or to be repaired. Our work addresses this design flow head-on. Our mission is simple: stop designing for waste and start designing for the longevity. That means modular PCBs, universal ports, and smart testing, because sustainability starts before the product even reaches the shelves. We combine technical reviews, global standard mappings, modular feasibility tests, and system level and build our solutions. If we don't act, e-waste will hit 74 million tons by 2030. That is a mountain of metal, plastic, and rare earths, most of which could have been saved with better design. Power electronics are the unsung hero of sustainability. They have reduced losses, protect hardware, and enable modular, upgradable systems. They are the engine behind the circular electronics. Let's talk impact. Just switching to USB-C could reduce 13,000 tons of charges waste per year. Imagine the effect if we brought that thinking, industrial equipment, labs, and smart infrastructures. Replacing outdated connector like VGA and VNC with standardized USB-C improves modularity, repairs, and future proofing. We have built a metric, the Component Life Cycles Index or CLCI, which score hardware on 5 key factors, including durability, toxicity, and reusability. It helps to push manufacturers toward sustainable choice of the start. Why throw an entire board when only one section is fails? Our answer: modular sub PCBs or daughter boards that can be unplugged and swapped like Lego blocks, and reversible soldering. And now you are talking a real repairability. Smart features like pogo pins, QR codes, and NFC tag make disassembly and reuse traceable, safe, and fast. We are applying the same logic to EV infrastructures. Open standard chargers like CC supports, upgrades, multi-brands use, and eliminate charger waste across models. The data in all universal charger win on reuse, upgradability, and sustainability. Multi-point hubs and POI switch eliminate the clutter, fewer wires, fewer remotes, and less waste. We propose a new benchmark, the Cross Compatibility Index, to ensure brands play and fair support sustainable inter interoperability. This does not mean useless. We recover ICs, test them, tag them, and certify them for powering everything from chargers to inverters. Robotic desoldering with blockchain traceability enables trusted, scalable, and efficient recovery at industrial level. But design needs backing. We recommend enforceable EPR, green procurement, incentive, and industry academia part to scale these solutions. Smarter product to know when they are about to fail. Sensors monitor states, AI predicts breakdowns. Together they guide repairs before the damage spreads. This is not theory. Our framework reduces raw material demands, energy loss, creates new jobs in repair, remanufactures, and testings. That real sustainability. From IoT device to government procurement, this modular, repairable, certifiable designs model is ready to scale. All it needs now is momentum. Before I even wrote the first word of this research article, one question echoed in my mind: can we design electronics that don't end up and as a waste. I wasn't just thinking as student, but as a user, as a citizen. I wonder what is institution and industrial and government work together, rethink how we build and dispose of electronics. This is research is my attempt to answer this. To conclude, power electronics plus smart design equals sustainable technology. We are not just trying to manage e-waste, we are redesigning its existence. This is not just a vision, it's a blueprint to power the future sustainably. All support data come from UNP, UE regulations, IEEE, IC, and peer-reviewed academic works. Thank you so much. We are open to question, ideas, collaboration to turn this research into reality.
Thank you so much for your presentation, sir. Meanwhile, Ayush Kai is presenting a paper on the title Textile Loop, a circular economy initiative in the textile sector. I request you to kindly take over with your presentation, please.
Sure, I am audible.
Yes, you're audible.
Okay. My screen is visible.
Yes, your screen is visible right
Okay. So first of all, good evening, everyone. I am Ayush Kayas, along with my teammate Rund Raval. We represent Sarvajanik College of Engineering Technology, Surat. We are excited to present our project titled the Textile Loop Circular Economy Initiative in the Textile Sector. This project is guided by Dr. Karen Kambatam from Oro University and Dr. Nirali Nanavati ma'am from our institution. And I would like to mention that this project honored as a top finalist among 600 plus global participant entries in CSI in international competitions. Let's Here is a roadmap of our presentation. Let's start with the introductions. India is a global powerhouse in the textile sector and significantly contribute towards the global textile market. We all know that great powers come with the great responsibilities. So as a responsibility part, we have to manage 7,800 kilotons of annual textile waste, which is 8.9% of total global textile waste. We did some study on Surat textile market, which is our hometown. Uh, Surat reusable textile waste like excessive threads, unfinished fibers, which is either ended up in the landfills or manufactured salad with the significant loss. This caused both environmental as well as economical loss. In our research, we studied some international market, which is a work on circular economy. For example, Good on You from the Australia, Certex from the Netherlands. So these models work on the concept called the circular economy. So what is the circular economy? Circular economy is working on reusable and recycling, unless traditional model like take, make, and dispose. Circular economy focused on the recycling and reusability. And these applications from Australia and the Netherlands work on C2C model. And as our aim is to build a B2B model, which is a pre-consumer based applications. So let's understand our problem statement. Our problem statement is pretty simple. Like there is a no in current situation, there is a no systematic or digitalized system to trace any reusable kind of trash or reusable textile stuff. So our problem is uh, two statement is just simple. Like it current textile market, there is a no centralized and digital platform who track down details of usable textile waste. By Textile Loop, we are solving this problem, and our objective is to map textile waste flow in India and clusters, co-develop digital solution with the stakeholders, enable traceable use of materials, foster industry participations in the circular economy. So, in our research methodology,
we built some focus group, which includes the industrial stakeholders and retailers. We take a feedback from them. We take a suggestion from them. What they are facing problems. So after the discussion, we build initial app, which includes some basic UI interflow, some chat applications, and we take feedback from them. And feedback was positive from them, their side. And as a graphical interface, if we understand our research methodology, so it's before textile loop, it's simply if our wastage is usable, like excessive threads or any excessive production, it's simply discarded in landfills or either sold at the significant loss. But after our applications comes in the picture, that reusable material is sellable. So manufacturer can make profit from that. So it's we highlighted portion that where our application take place. And let's talk about technology. We use Flutter for the development, so we can deploy our application in Android as well as Apple uh, mobiles. So as a backend, we use Upright and Dart as a programming language. We use traditional MVC architecture for our applications. Our application has different modules like listing, search, in-app messaging, order management, and admin access. And our Upright backend is allowed real-time database operations, secure authentications, role-based access control, and open source hostings. These are some screenshot from our applications. And after the testing, we received some positive as well as some negative feedback. Like stakeholders like traceability, chat features, and resale opportunity. And civic body excited about collaboration possibilities because these applications expand their industrial network. But as a challenge in the textile section, there are some old age people who are dealing businesses. They are not comfortable with the digitalization. So maybe new generation overcome this problem, and definitely this gonna be helpful in textile industry. And for the future work, we are planning to integrate some AI features for the smart material categorization. We are planning to add some gamification like some badges or point system that so that user are engage with our application. We planning to build like some dashboard, how much percentage you save uh, environment or you CO2 saved by you. And we are planning to implement augmented reality or AR products so user can easily say that quality of product is good or not. And in future we might expand up to C2C model from B2C and B2B model, from B2B to B2C and C2C models. In the conclusion, textile loop is not just an application, it's a systematic solution for the Indian textile market for reusing textile waste. It understands the small and medium enterprise and offers them traceability, transparency, and digital trading. It's a tech-enabled, stakeholder-tested, and policy-aligned applications. And these are some references we used to make our paper. Thank you. That's it about my side.
Thank you so much, sir. Due to some technical issue, our chair is not available with us right now, as she has mentioned in the chat as well. Do we have anybody here in the session who wants to ask any questions to sir on the presentation? Okay, so looks like everybody was satisfied with the presentation, sir. Thank you so much for presenting. Now I would like
Thank you,
to,
sir.
yes, thank you so much for presenting. Now I'd like to present the presentation for Sumangala ma'am. For on her behalf, I'll be presenting it.
Am I audible, ma'am?
Yes, ma'am, you're audible. I'll start with the presentation. You can start explaining it.
Thank you for your support, ma'am. Good afternoon, everyone. I am Sumangala Basavaraju Donknavar, student from KL Technological University, Hubballi. It's privilege to present our paper titled Sentiment Analysis from Kannada Text in ICT4SD conference. The co-authors of this paper are Lakshmi Sanjay Badige, Kirti, and our guide, Professor Satish Chikmatsa. In this presentation, I'll be sharing the motivation behind our study, the approach we followed, the results we achieved, especially in the context of natural language processing for regional Indian languages. So here is a brief overview of the presentation flow. We will begin with the introduction and motivation followed by the objectives of our work. Then I will explain the methodology, evaluation metrics, and share the results. Finally, I will conclude with the key takeaways and references. Sentiment analysis, also known as opinion mining, is a subfield of natural language processing that aims to identify and extract subjective information such as emotions, opinions, or attitudes from text. It is widely used in applications such as customer reviews, social media monitoring, and public opinion analysis. While many models and tools are available for English and other global languages, regional Indian languages, especially Kannada, still lack adequate resources, datasets, and models for effective sentiment classification. This gap motivated us to focus our work on Kannada. Coming to the motivation, the primary motivation behind our work is the lack of sentiment analysis tools for regional languages like Kannada. While English has abundant data sets and tools, Kannada remains under-resourced. At the same time, Kannada is widely used in digital communication platforms like WhatsApp and Facebook, increasing the demand for language-specific analysis. This project aims to address that gap and support inclusive AI by promoting linguistic diversity. Next, we proceed to objectives. The main objective of this work is to develop an effective sentiment analysis model for Kannada text using deep learning. This includes building a pre-processing pipeline to clean, tokenize, and prepare the text, and implementing an RNN LSTM-based model to classify sentiments as positive, negative, or neutral. The project also aims to handle the linguistic complexity of Kannada to improve accuracy, design a user-friendly interface for ease of use, and evaluate the model's performance using key metrics like accuracy, precision, recall, and F1 score. Now let's move on to the methodology, which describes the step-by-step process used to build the sentiment analysis model for Kannada text. As shown in the block diagram, the entire pipeline involves data preparation, text cleaning, tokenization and padding, train test split, RNN model design, model training, model evaluation, and finally sentiment prediction. The first step was data preparation. We began by uploading 3 Excel files. Each file includes 1200 data sentences for each sentiment. Each dataset was in Kannada language. We assigned sentiment labels as for -0, for neutral 1, for positive 2. These datasets were then combined into one and cleaned to remove unwanted characters, empty entries, and extra white spaces. Once the data was prepared, we moved on to text pre-processing. The first sub-step here was text cleaning. We removed punctuation marks, special characters, and empty rows. This ensured that only meaningful textual content was passed to the model for analysis. After cleaning the text, the next step was sentiment labeling. We realized the sentiment values explicitly as for +2, for neutral 1, and for -0. This numeric encoding helps the model understand and predict sentiment categories efficiently. The next step in the pre-processing pipeline was tokenization. Using the Keras tokenizer, we converted each Kannada sentence into a sequence of word tokens. Every unique word was assigned a specific integer index. This step was essential to convert raw text into a machine-readable format. After tokenization, we applied padding. Since different sentences vary in length, we padded shorter sequences with zeros to match the length of the longest sentence. Padding ensures consistency and allows us to feed input to deep learning models that expect fixed length sequences. Once tokenized and padded, we split the data into three parts: 70% for training the model, 20% for testing, and 10% for validation. This ensured proper evaluation of the model's performance on unseen data. With the data ready, we moved on to designing the recurrent neural network model. This architecture uses long short-term memory (LSTM) layers, which are effective for handling sequence data like text. The architecture consists of an input layer, an embedding layer, two LSTM layers with dropout regularization, and a final dense output layer with the 3 units corresponding to the sentiment classes. Input layer. The input layer, it receives the pre-processed Kannada text represented as sequences of integers. The embedding layer converts these integers into dense 128-dimensional vectors. This helps capture semantic meaning of words based on their context. The first LSTM layer learns sequential patterns and captures the contextual relationships between the words. To prevent overfitting, we applied a dropout layer that randomly deactivates some neurons during the training. A second LSTM layer further refines the sequence learning and deepens the understanding of text sentiment. Next. Another dropout layer is used again for regularization and generalization. Finally, we used a dense output layer with 3 units, one for each sentiment class. They are positive, neutral, and negative. We applied a softmax activation function to get the probability distribution across these classes. We used evaluation metrics, accuracy, precision, recall, and F1 score. A sentiment classification model was evaluated using 4 key metrics as mentioned earlier. Next. Okay, thank you. For the negative class, all 3 metrics, precision, recall, and F1 score were 0.87. This shows the model is consistent and correctly identifies negative sentiments most of the time. For the neutral class, the model performed previous slide. Okay, thank you. For the neutral class, the model performed best. It has the precision of 0.99, which means nearly all predicted neutrals were correct. For the positive class, the recall was again 0.90, showing the model catches most positive examples. However, precision was slightly lower at 0.82, meaning some incorrect examples were labeled as positive. Still, the F1 score of 0.86 reflects good overall performance. Based on these metrics, we estimated the overall accuracy of the model to be around 89%, assuming equal class distribution. This indicates that our model performs reliably and is well suited for sentiment classification tasks. Next slide, ma'am. Thank you. So these are some of the results. For positive sentiment, the input data is Avanu chennagi haduvanu, which means he sings well. As it is a positive sentence, our model predicted it as positive. Similarly, for negative, the input text is Nanu samayadalli baralu sadhyavaguttilla, which means I cannot come on time, which is a negative sentence, and our model predicted it as negative. Similarly, for neutral sentiment, the input text is Nanu ಶಾಲೆಗೆ ಹೋಗುತ್ತಿದ್ದೇನೆ, which means I am going to school, which is a neutral. summarize the work, our model effectively classifies Kannada text into positive, negative, and neutral sentiment categories. The use of RNN with LSTM layers helps the model capture both context and sequential structure of words, improving accuracy. Pre-processing steps such as text cleaning, tokenization, and padding play an essential role in preparing quality data for training. While the model performs well with structured Kannada input, it may still face challenges in handling ambiguous and sarcastic sentences. This work underlines the growing need for NLP tools tailored to low resource languages like Kannada and demonstrate that such tools can be built effectively using deep learning techniques. These are the some of the references we referred for our research. That concludes our presentation. On behalf of my co-authors, I sincerely thank you for your time and attention. We also extend our heartfelt gratitude to the organizers of ICT4SD for providing us with this valuable platform to present our work. We are happy to take any questions or feedback. Thank you once again.
Thank you so much, ma'am. Do we have any questions from the session? Any participant? Okay. So thank you so much for your presentation, ma'am. With this, we are. Thank you so much. Now, with this, we conclude our session for today. I sincerely thank you, our authors, for your excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of this conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springers. Publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. Now, I just request all of you all to kindly switch on to your cameras for a quick snapshot of this virtual conference we just attended. Requesting all to kindly switch on to your cameras for a quick snapshot, please. Thank you so much. Stay safe, take care. Meet you in 2026 for the next session. Thank you.